So thank you, Vishal, so much for joining us on this call. The first question I have for you is, how would you explain tinyVision to someone who's completely new? Like, how would you explain what tinyVision.ai is doing?
Okay, so there are two parts to tinyVision. One part is helping companies develop new products. So if you are building an edge vision device, let's say medical imaging device like a probe or surgical robot kind of stuff that requires visual input, we work with those companies to uh, create the camera and bridge the camera with the computer. So we have a hardware and software solution that allows you to plug in up to 5 cameras. So you can take 5 sensor inputs. It typically is camera, but it could be any sensor that is MIPI out from the sensor, and then converts that into a USB stream over UVC that goes to host computer. So most of the solutions on the market are one-to-one. We have one sensor connecting to a microcontroller board that feeds it to the host computer.
Okay.
Ours is the FPGA-based solution. Ours is the only solution that can take in multiple feeds and then either stack them or we can stitch it whatever way you want, either as individual streams or single stream, and give it to the host computer. Very low latency, very low power requirement, 180 milliwatts is what the thing will consume. So what we do is we take the concept to the hardware design, we do the firmware, we do the interfacing, component sourcing, bill of material, and we take it to the prototyping stage. So we have access to a manufacturing facility in the US where our office is in San Diego. The other part, which is more interesting here, is we build FPGA-based educational boards that makers, hobbyists, and students can use to learn FPGA and RTL programming. And there we have 2 different products, and a lot of colleges and universities in the US and Europe use our board to teach digital circuit design courses. So starting from like logic gates all the way up to even AI at the edge, because most of these devices have enough capacity to do basic AI stuff like image processing and all, recognizing that there's somebody in the field of vision, there's a human or car or something. Interestingly, we have also seen some a lot of companies buy this board to build prototypes of what they're doing. So, for example, one of the companies bought these boards to build controller for automated pizza oven.
Okay.
So, and we didn't know about what they're buying, but later on, when we're talking, then they said this is what they use, and and the reason you use it because it's simple. It's FPGA based, open source toolkit, and because it is FPGA, you could practically do anything you want with it.
Right. So this is really interesting because as a company, you are into end-to-end solution providing as well as building open hardware for makers and engineers to understand and experiment the technology on their own. So why this focus on engineers? Why there is a focus on creating development boards? What is the need for that?
Okay, so there's another interesting story behind that. So Venkat Rangan is the founder of the company. He started the company in 2018, and Venkat and I go back a long time. We studied together, so we're in engineering. So Venkat worked at Qualcomm for about 25 years in R&D, and then he came out and he just was fed up with corporate stuff, So he came out and he just started tinkering. He's always been a tinkerer.
Okay.
He started, I want to build something, right? So he said, I'll build this board that I can use to do lots of stuff I want to do.
Okay.
So he built this first board, which we call UPduino. It's a lattice ICE40 FPGA-based simple board, very small board.
Mm-hmm.
And actually, he started. His idea was okay. There's a lot of at that time in 2018. There's a lot of noise about things happening at the edge. A lot of IoT stuff and edge and AI happening.
Mm-hmm.
So he said, okay. He had worked on camera space quite a bit. So he said, okay, let me build a company that provides solution in that space. And so initially, when he came out, he just built that board, and then he started seriously working on the company. So the solution came, engineering solution came after he had built that initial board, and then once he built it, he said, "Oh, he showed it to some people, and they liked it." And then one of his friends was a professor; he wanted to use it. So he said, "Okay, this seems like people can use it." So he actually converted that into a product with all the documentation stuff.
Okay.
And then, so the tinkerer side of him
Mm-hmm.
wants to build these boards.
Okay. That's
Then, then we build this board we call Pico Ice, which which combines Raspberry Pi
Mm-hmm.
with this ICE40. So it's a board that has Raspberry Pi, and then there's the ICE40. So there's a microcontroller and FPGA together on the same board.
Uh-huh.
Again, he built it because, and it's he wanted to build something. Okay. And again, it has a unique combination. Either you get like a microcontroller or you get a FPGA stuff. You rarely get the two things combined.
Mm-hmm.
And we recently upgraded that to Pico 2 Ice. So the earlier one was using RPA 2340
Okay.
processor MCU, and now we have that upgraded to 2350B. So it's a much faster microcontroller now. The FPGA remains the same, but overall it's a much more powerful board for makers or anybody who wants to learn about these things.
So I think most of these development boards also align in that direction only. But why FPGA? Why are all the development boards that tinyVision builds are based on FPGAs?
I won't say there's like a very specific logic to it.
Mm-hmm.
It was more like, okay, there's a lot of microcontroller stuff. Can we do something with FPGA? So they started that. But then what happened was we started working very closely with the Lattice Semiconductor.
Okay.
Which is primarily a FPGA vendor, OEM. And we started doing a lot of reference design and boards for them. So we kind of built a specialization in using FPGAs. And because of the nature of the work we do in engineering side, a lot of the times either there's going to be microcontroller or an FPGA that's needed to build your product, right? FPGAs, because of their versatility, it becomes easier to prototype things there. Till you figure out, okay, this is a particular microcontroller I want to use based on the features, and I need the power, processing power, power consumption, and all that stuff. So a lot of the time during prototyping phase, you're trying to figure out what is possible, and you're not really decided a particular SOC or controller that you're going to use. So FPGA becomes kind of a good starting point to do that for prototyping, right? So that's where it started on FPGA, and then we became a specialist in that. Doesn't mean we don't work with other. We work with microcontrollers and other stuff as well.
Okay.
But low power is definitely one area we specialize. We don't want to go to, for example, an NVIDIA device, which is going to be a very different ballgame, in terms of power and processing capability and all of that. Although we recently built a system for a client using an NVIDIA box. Okay. But that's not what I will say our specialization is.
Okay, great. Now let's talk about these two famous development boards from tinyVision. One is the UPduino and the other is Pico 2 Ice. Yeah. So as an engineer or someone who is starting to use FPGA, who's this board targeted for, and what is the special purpose or what is the application for these boards?
Sure. So one of the special things is typically when you're a student and you want to learn about FPGA and very SDL, right? So programming, Verilog, or whatever you want to use. Most places, either you will go to your college and the college might have a like a Xilinx or some other board there, right? As, but as an individual, you can go to the lab and work during allotted hours, right? But you have certain number of hours.
Mhm.
As an individual, if you want to do that, these boards are quite expensive. They can run into couple of $100, sometimes $300, $400. UPduino costs 34 or $35.
Mm.
Sure, it doesn't come with all the peripherals that you want, but you can. Our idea is that you can pick and choose the peripherals you want. So you want to build a display driver, you can buy a 8-segment display or an LCD display and hook it. You want to build a camera thing, you can buy a Raspberry Pi cheap camera for maybe $10-15 and connect it, right? So the core platform itself is like 1/6 to 1/7 of the cost of a typical FPGA learn educational platform.
Mhm.
And the other thing is you can use MicroPython if you know MicroPython to program this stuff.
Mhm.
And it's all open source. The Toolchain is open source, so you don't need to go to AMD or which now owns Xilinx to get the Toolchain, right? You can use open source stuff uh, for programming. So what happens is if you're an individual, you have this board, this small board, always with you because you can buy it $30 about what 2,500 rupees or whatever, right?
Right.
You can buy an own one if you really want to learn.
Mhm.
And most of the colleges we found professors use it because of the same reason. They say Xilinx board is in the if I use that, it's such an expensive device, it has to be in the lab.
Mhm.
So the students get very less time to work on it. With this, what they do is if there are 40 people, they'll buy 40 boards, give one to each of the students
Mhm.
who can take it to their dorm or hostel or apartment, wherever, and use a laptop to work on this anytime they want. So it
Mhm.
gives them a lot of flexibility in terms of where they work, how much time they can work, and what kind of project they can do. Because
Mhm.
if you have only 8 hours or 10 hours in a semester available, you can't do really, deep dive projects on that.
Correct.
But if you have it available all the time with you, you can do a lot more. You can do something that takes 30, 40 hours because you have the board with you.
Mm.
So that's why people use it.
Right. Perfect. So say I am an engineer who is very interested to learn FPGA, and now I have two options in front of me. One is the UPduino and the other is Pico device.
Right.
Which one should I select and how should I get started with it?
So the basic difference, right? Like I said, is the Pico 2 has a Raspberry Pi microcontroller. So it's a little bit more powerful in that sense because you can combine the power of the two, right?
Mhm.
So if you only want to learn about FPGA, go with UPduino because
Okay.
it's simpler. It's uh, it's also slightly cheaper than I think $5 or $6, probably cheaper than that.
Okay.
But if you're interested in building some project or learning about microcontrollers also,
Mhm.
go with Pico 2 because you get both options there.
Right. So one thing that I have always found a bit difficult with FPGAs is there is not enough documentation out there for a very
Yes,
beginner to get started and learn things from the basics. And like
right,
you told, most of the boards, the tool chain is also behind a paywall, and it's not easy for a student to get started with it.
right.
How does that change with the boards from tinyVision?
Okay. So first thing is that the toolchain is open source, so you don't have to rely on when you don't have to really buy anything there. Then in terms of support, we have a very active Discord community
Mm-hmm.
with several thousand people who are on the Discord channel.
Okay.
Uh, so you can join the Discord channel, and people are discussing their projects there, and if um, and helping each other out. Right. So if I'm building, a controller for, let's say, I'm building a camera device, right? And I'm building a for my computer I have to use in my with my laptop, right? You can go there and find out, okay, what if you have issues, you can find out how to interface it, which sensor would be, better suited for your need, if what kind of compression to use, what ISP to use. So you can get a lot of that support on the Discord channel. You also get lots of project ideas because people are discussing there. So you can see, okay, this guy is building something interesting. Let me just copy that, right? So that makes it easy for you to solve your problems. We also provide detailed, documentation in terms of pinouts and what you can do with these boards to get you started. We are also in the process of actually working with a couple of profs to put together educational deck. So like a structured course deck. And some sample projects that you can do. So right now, we don't have that sample projects documented in a way that you can just say, okay, I want to do this and let me just follow the instructions and do it. So you'll have to go to the Discord, join the Discord community and get a few things answered there if you can't solve it yourself. But what we are trying to do right now is get this at least 4 or 5 starter projects kind of done step by step. So anybody can come in and say, okay, I want to build this. If I follow these 10 steps or 200 steps, whatever it takes, this will work.
Right. Interesting. So one more thing, like I mentioned earlier, when we talk about tinyVision, the thing that immediately comes to mind is those 10 kb face detector and voice recognition and stuff like that. So does these boards also have support for that? Like, do they have, what is the edge capabilities of these devices when it comes to voice and image processing?
So in terms of image, yes, there's capability to hook up your camera and do processing on the edge. In fact, that's one of the projects we're trying to document right now is one of the US universities, people using UPduino, they built edge AI, edge image processing. So it's not very sophisticated, but it does detect like a face detection. It can't detect it's Vishal or it's you, it's Abhishek and anybody, but it can detect that there's a human face in front, right? So it can detect that. And it's it's really not meant for really very deep down application. It's more for people to learn. So that kind of detection is possible. In terms of voice, again, you can do wake and sleep keywords and those kind of stuff, and based on that you can trigger your application. Again, it depends, basic. So the basic limitation is that the memory, right? How much physical memory is on the board, and the FPGA is very versatile. You can do processing there, but then again, it's limited by the number of LUTs it has, right? So it's logical units it has. So the ICE40 is one of the easier and simpler FPGAs. So there's limitation in terms of how much you can do processing, but there's enough for you to learn this stuff. We do work in audio and model. In fact, we are working with one of the chip companies to build some applications for their microcontrollers and chips. But those are much more sophisticated because they require a lot more processing capacity than what a simple FPGA like ICE40 can do. If you go to Pico 2, you can obviously do a lot more because you also have a microprocessor to offload some tasks to it. You can do a lot more there.
So actually, it's really nice to know that tinyVision is focusing on this open hardware ecosystem and even has a dedicated Discord community to help people learn and grow together. So what more is tinyVision contributing to this hardware development platform for the engineers and makers of that?
So it's a very, very good question. And like I said, the whole thing is because of the the companies are built around the founder's DNA, right? So Venkat started it. I joined him later. So I'll tell you a story about Venkat. So when we were in college, he's always building something, and
Okay.
in the hostel, the moment you open the door latch, his music system will go on. So yet his on-off switch was in the latch, right? So if you close it, it's off, right? So um, the moment you open it, the contacts close, and then in the relay will close, and then his music system goes off. And he built his music system himself.
Okay.
We also built speakers and all that stuff together.
Mhm.
So, so that's that DNA continues, right? Now one of the other, and the reason we focus so much on open source is because, like I said, it's easier for people to learn. And in software, the open source is everywhere. The hardware, it wasn't that big. It is starting to become big with Pi and all of that stuff. In fact, yesterday we had an event. We participated open source hardware event where we showcased the product and how we built. So it's not just about building the product, but you also show how we built it. How we came up with the idea. How do you, if you want to build an open source product, what are the steps you should follow? What kind of facilities you need? You showed them the machines, SMT machines that we use to, build these boards, test how you test it, and everything. What we have also done is we contribute a lot to Zephyr, which is the RTOS.
Okay.
So we are a very active contributor to Zephyr. We have built our own image processing library for Zephyr that's being used by a lot of chip vendors now. So it's out there. If you have the capacity, you can take that library and port it to your platform. Otherwise, we can help you port that library to your platform. We are working with some of the big chip vendors to port it to their platform. We also have USB side, a lot of Zephyr stuff that we have done that we have pushed upstream. There. So we, as a company, we are very committed to open source, because we benefit from it. When others build, we benefit, and we want others to benefit from our work. And it's also, I would say, there's this industry trend on the hardware side also, because unlike software, if you take out Microsoft, there's a lot of Google is probably the big pusher of open source, right?
Right.
And everyone wanted to push open source because everybody was competing with Microsoft.
Right.
So on the hardware side, but if you see traditionally, it's a very close ecosystem. Each hardware vendor had its own tool chain and applications, and you can't really, there's no open source concept there. But in the last few years, that is with open source RTOS coming along, there's a lot of stuff happening there. So a lot of companies also want to, like Nordic Semiconductor, I know is very big in this space. They're pushing Zephyr a lot. So there's a movement there, and we want to be part of that. And we like it. We have capacity, we have intent, and we do it, and our customers also want it. So everything comes together in that sense.
This kind of makes me happy to see all these open hardware initiatives, because like you told, in software side, there are so many initiatives for open source, but on hardware, I think the movement is just starting. So from your personal point, how do you see the adoption for this open source hardware? Because even the development boards we talked about, I'm sure it's being sold globally. So if you have to talk about in a geographical sense, how do you see the adoption for these open source technologies?
So we are seeing very strong uptake from the industry, especially in the last maybe 1.5 to 2 years. Initially, there are only selected companies that are pushing it. But now I think everybody feels the need because customers have started asking for it. Customers don't want to be tied down to proprietary systems, right? There's still a long way to go. But for example, if you take sensors, right? optical sensor. Each sensor has proprietary drivers and stuff. So if you want to, if you build an app device that uses on semi sensor, and you want to switch to Sony sensor, now you got to write entire driver for the new sensor, right? Because the register is going to be different, setting going to be different, and stuff like that, right? So, so that there's still some distance to go, but at least on the microcontroller and SoC and that side, we see and Zephyr is probably the most popular open source thing happening right now. And so everyone is building those libraries on top of that. So the one limitation is that, you know, anything you do in software is slightly slower than what you could do in hardware. So if you implement the same thing in hardware, it's much faster, but then it's also more expensive into design and build. And it's but on the more general stuff, wherever you can use software libraries, I think this adoption is increasing quite a bit. Like I said, there's this show Electronica where we met, right?
Okay.
And I talked to a lot of chip vendors that were there, even some of the Chinese ones.
Okay.
And even they are like, we want to build application solutions on Zephyr because customers are asking for it.
Okay.
So there's a lot of pull for that. And I think in the next couple of years, I think even the US is seeing that. Europe initially was the big pusher.
Okay.
And now we see that the US, a lot of companies have also taken to it. And wherever US goes in technology, everyone else follows.
That's true. That's true. So one final question from my side would be, what can we expect from tinyVision moving future? What is exciting for engineers and makers? What can we look forward from tinyVision.ai?
Sure. So one is that we are building on, we're thinking about our next board, which we are tentatively calling it pico-next.
Okay.
And we want to make that a little bit more evolved than Pico 2 in terms of capability and all that.
Okay.
But it's some distance away right now.
Any sneak peek, like what new would be there? Like what's new in this?
So we haven't decided. We just decided, okay, let's build the next one. But
okay.
So we have asked our community and about what they would like to see. So the way we build is we ask the community, and we are thinking about building the next iteration or next stuff. So when we built Pico from UPduino, right, we asked the community, would you like to have a microprocessor on this board? And the overwhelming response was yes. So we built that. So we asked our community, okay, what next you'd like to see in the board, in the next version of the board? And then we go back and decide, okay, what we need to do. So we are in that process of doing that. We'll continue to push very hard on the Zephyr open source stuff, whether it is for a client or we just build it ourselves for in our products, and we push it upstream wherever we can. Sometimes you can't put because it uses a vendor or OEM stuff, so you can't push it. But wherever we can, we are pushing very hard on Zephyr ecosystem. And in terms of engineering projects, it's more driven by what the client needs. So if the client says it's proprietary, we can't do anything about it. But wherever we can include Zephyr or any other open source stuff, we do push that. And we continue to invest in the Discord community. We continue to support that. We continue to work with colleges to drive, this adoption of open source hardware and software in those curriculum. So more people can learn, more people can do more stuff because it's all open source.
Right. So
at a much lower cost. Right? So our accessibility, affordability is very important for us, and we continue to push on in that front.